Okay, I'm going to get you started on this problem. We're going to start with the first part of the problem, which is asking you about the perimeter or the length of this shape. And one of the things that you can do is he's made a note that this is also known as the Koch curve. And if you look it up online, you'll find lots and lots about it. Even the wiki page is really helpful in terms of showing you how to find both the perimeter and the area for this particular problem, okay? So I'm going to explain to you what's happening here in terms of the perimeter and try to show you the pattern, and then I'm going to let you develop it from there since this is a marked assignment. So we have our equilateral triangle, and we're starting with all of the sides as one unit in length. And how we're creating the next shape is that 1/3 of the way along, we are just taking two little line segments that are both of equal length, because we're making equilateral triangle, remember? So they're equal to the length that we're cutting out of the triangle here. And we're building those off the side of the original equilateral triangle. So, whoops, didn't mean to do that. Well, maybe it won't let me erase that, will it? No, it won't. That's why. Okay. So I wanted to erase the side once I had built that out. But we'll just do it like that, okay? So if this is 1/3 of the length of the original side, then that means that all of the sides, because this is an equilateral triangle, are going to be 1/3 in length. And we do that 3 times because we're doing that off the side of each of the original sides. And so now, instead of having a perimeter, the original perimeter, so perimeter of term 0 was 1 plus 1 plus 1 equals 3. For the first changed shape, we have this sort of star shape, and now the perimeter is going to be 4/3 plus 4/3 plus 4/3, okay? And we could write that as 3 times 4/3, couldn't we? Up here, if we wanted to go with the same pattern, we could write this as 3 times 4/3 to the exponent 0. And this would be 4/3 to the exponent 1. And I think you see where we're going with this. So the next one is going to build a triangle off of each of the little sides on the second diagram so that we end up with the third diagram like this. And so if we do that, I haven't got enough triangles there, but you get the idea what we're doing. If you do that, then your perimeter for the second one is actually going to add another 4/3 in length, and so we end up with 3 times 4/3, and this time it's going to be to the exponent 2. So I think you can see the pattern developing here. And the answer that you're being asked to give here is not to find a general term for the perimeter, but to think about what happens as we get to the nth shape in this series, and whether or not we can find the length of that. And so in calculus terms, I think what they're really asking is there a limit to the length? We're always adding on to each side. We're always adding 1/3 more onto the length of each side as we keep dividing this up and dividing it up. Does it start to approach a limit as we get to a large number of these shapes, or is it going to continue growing forever? And you have to make that decision from the pattern that you're seeing here and determine whether or not there is a value or whether there's just an infinite value for the length of the snowflake shape. So that should get you going really well, I think, on part 1. Again, I think that if you go online and you look up this Koch curve, you'll see a lot more stuff about that, and it will also help you get started on the area part of the problem as well. Just keep in mind for the area that you need 1/2 base times height for the area of a triangle. And because we're dealing with the equilateral triangle, our perpendicular height will be right through the center. So the hypotenuse will be 1, this base side will be 1/2, and this side here is going to be 1 squared minus 1/2 squared, and square rooted. Okay, and so that side of the triangle for the height, the altitude of the triangle, is actually going to be the root of 3/4, or you could write that as 1/2 root 3. And so that's going to be, when you're finding the area, and you need 1/2 times the base times the height, you're going to need 1/2 times 1 times root 3 there for the first triangle. And then you're going to have to figure out how the area is affected by building those other triangles on the side here, each with length, side length 1/3. You're going to have to calculate the height for those triangles so that you can find the extra area that's being added on each time. So I hope that helps you get started on this problem. Feel free to email me later in the week when you've had a chance to look it over and look for some other resources. And I'll be glad to help you further if you need more help.